All right. Good morning, everybody, and welcome to this exida webinar. Today we're going to talk about exSILentia version 4 and what will happen to your existing exSILentia version 3 files. So we're going to review our forward compatibility and any impact upgrading to exSILentia 4 may have on your version 3 files. As always, audio is provided via the GoToWebinar application. Please enable your speakers, and your microphone has been muted. If you have any questions, on the right-hand side of your screen, you will see the GoToWebinar control, and you can ask questions right there. And as they come in, I will try and answer those questions. My name is Yvonne van Beurden, and I'm the Chief Technology Officer, Director of Product Development here at exida. And in that role, I'm responsible for development, maintenance, and certification of exSILentia. In addition to that, I work with end users and manufacturers, as well as a functional safety assessor, both for IEC 61508 and IEC 61511. I'm the current director of the ISA Safety and Cybersecurity Division. I'm a member of the IEC 61511 maintenance team, as well as ISA 84 committee. And to start, a quick overview of exida. As you may know, exida is a company that is based on the foundation of the company is based on 3 pillars. We have a group of people that work in the certification and assessment area. They will evaluate products that we typically use in the process industry, anything from transmitters to valves, logic solvers, etc. That group also deals with automotive industry, the robotics industry, and others. So it's not just limited to the process industry. We have a group of what we refer to lifecycle services consultants. Those are people that do anything from the PHA all the way to the decommissioning of your safety and cemented system. We will not actually operate your equipment, but we will help you in specifying your proof tests, executing your proof tests, and executing your main modification plans like a decommissioning, but anything in between as well. And then the third group, that is our enterprise tools. That's the group where I spend most of my time, where we develop software packages like exSILentia and SILstat as one of the modules within exSILentia, and the silver tool that you may be familiar with. As I mentioned, a variety of industries. So we have an office in the Munich area in Germany that's very heavily involved in the automotive industry. But we do many projects around the world, LNG projects in Australia, offshore here in the Gulf of Mexico, and so on. So for today's webinar, where we're going to talk about what will happen to your version 3 files when you upgrade to version 4, maybe the first question that we should ask is, why do we want to upgrade to exSILentia 4? What is the benefit of that? So I put a couple of slides together just to review the benefits of exSILentia 4. Obviously, it's a major update on our platform, and you may have heard this or seen this before. The software is set up such that all the data is captured in a centralized data core or data stack, where it's easy to access information from one phase in the next phase of the life cycle. The exchange of information makes this a really powerful tool. I've actually, this morning I was looking at a PHA that was done by one of our customers in a spreadsheet, and we were trying to figure out how can we easily get that information over to a layer of protection analysis. How can we get that information easily over into our alarm rationalization software, SILalarm? And the answer was, well, it's going to be a big manual task to do this. In this case, there wasn't even something that was easily importable. Causes and consequences were all mixed in the same cell within the PHA. And that's one of the things that exSILentia 4 does. It allows you to easily exchange that data between different phases of the life cycle. Obviously, we updated many of our tools, additional functionality, and we introduced some new tools within the software as well. So you may have seen that we have a standalone layer of protection analysis tool now. We're in the process of releasing a CyberFacts and a CyberSL tool, all embedded within the exSILentia framework. So we have the intelligent lifecycle integration that is applicable to exSILentia. We move data throughout the lifecycle, and the individual tools are very powerful. You can get our PHX tool, our LOPAX tool, as a standalone products, and they can make sure that you're compliant to the standard and you use all the benefits of the tools. But the power really comes from being able to move the data from one phase to the next. And as we have a project where we're dealing with a particular set of data going from one phase to the next step is to be able to exchange that data with other systems. So the individual tool layer that you've seen in our data stack, that represents that you can use the silver tool all by itself. The project layer is the representation where we use all the tools as a cohesive entity, and we move data from one phase to the next. Then the database layer on top refers to the ability to populate your master alarm database, for example, for a variety of control systems. The configuration layer allows you to exchange or allows you to transfer the knowledge that you've captured in your SIL verification and your design safety requirement specification, and automatically generate the configuration logic for a safety PLC. And then the final layer, the access layer, talks about the interfacing with CMMS and ERP systems, where we exchange data on the enterprise level. For example, when you start recording proof tests, your proof test frequencies, your work orders, etc., all that is interfacing with our SILstat software. So in this overview as to what will happen with our exSILentia version 3 files, we're going to focus primarily on the silver tool. And so some of the features, key features that I want to highlight for our SIL verification tool is the fact that it's compliant with the latest standards. So IEC 61508 2010, okay, that's been on the market for a while. IEC 61511 2016, soon to be ISA 61511. Those standards are part of the starting point of our overall tool development. So with this version of the standard, with this version of exSILentia, you're compliant with these latest standards on the market. One of the other things that I think is very powerful is that you as a user have control over your default settings on some of the key parameters. So instead of having exida defaults that you may need to update every time, you can set your defaults early on in your project configuration, and then basically whenever you create a new safety function, those are the defaults used for your particular SIF. There's an improved ability of reusing sensor fine elements and logic solvers. You're able to create a project-specific device database. So as you are modeling your safety functions, you're going to select equipment out of our equipment database, the Safety Equipment Reliability Handbook, or you're going to define your own data, and all those items are embedded in a device database that will allow you to easily select from in subsequent SIFs. And then last but not least, we have significantly enhanced the logic solver to the point where we take into account how you wire the field devices into the logic solver, and how you wire a I/O channel onto an I/O module, and we can basically create a virtual image of your eventual cabinet with the knowledge that we have within the tool. So just as a highlight again, within the project settings of exSILentia 4, you're able to specify these default project parameters. So for example, you can say all my sensor groups should have a mean time to restore or mean repair time of 24 hours. Or the mission time for my safety function should be 20 years. Or the beta factor for all my final elements needs to be 10%. That's stuff that you can define up front, and then whenever you create a new safety function, it will automatically take those defaults. We talked about the reuse, so we can easily reuse sensors and fine elements. There's no longer a need to mark a sensor group or fine element group as a reuse, because everything in exSILentia 4 revolves around this data core where we have libraries of information. Every sensor group, every final element group is a library item, and it's just a matter of simply selecting that particular item from your drop-down list when you're modeling your safety function, and you're done. You're done, configuring that group. Obviously, any changes you make to that particular group are automatically applied to every single instance where that group is used. So the reuse of information is highly improved within exSILentia 4. And again, that helps in creating that actual image as to what your safety instrumented function looks like and what your overall safety instrumented system looks like. Device model database, I talked about that very briefly. So in the screenshot here, you'll see the device model library. You see all the device models that are specified in the bold font. Let me see if I can get my highlighter here. Or the spotlight better. In bold font here are all the device models that were selected from the Safety Equipment Reliability Handbook database. And the one at the bottom here in normal font, and the one that's currently opened, is the user-defined, and in this case it's a solenoid, the user-defined solenoid. And what this means is this particular item is in my database. I can go in at any time within my overall project library and make changes to that particular item, and they're applied everywhere. So if you have a user-defined entity that needs to be updated throughout the project, instead of having to go back to every single instance, you update it in one location and it's deployed everywhere. Then finally, the logic solver. So in this particular screenshot, what you see is, let me highlight that. What you see is a simple safety function, single input, single output, a second safety function with a single input, single output. And you can see in the module allocation in the logic solver that module 3, which happens to be an analog input, has an analog in PT101 on channel 1. And then for the second safety function, you see that same module, number 3, has on the second channel TT101. So we keep track as to where the different I/O channels land within your safety function. Once you, as a question here with regard to the default parameters, so and the question is, if I specify default parameters, can I change them later? And the answer is absolutely yes. So the only thing you do with your default project parameters is to specify that initial value. On a per safety function basis, you can change the value. So if I take the example, I'm taking a fine element and I say the default beta factor for fine elements should be 10%, and then I go in and I conclude that I use diverse equipment and I follow my checklist basically of what makes things less susceptible to a common stress. I could override that 10% and make it 5% or 2%, whatever is applicable for this particular safety and semantic function. So yes, the default parameters are overridable at a later date. All right. So Let's see if there's any other questions. No, that's it. So that's just in a nutshell some of the reasons why you may want to upgrade to exSILentia 4. The whole data core and the data stack was explained last week in last week's webinar by my colleague Kate Hildenbrand. So if you want more information on that, go to YouTube and look that up. But for now, we're going to go back and dive into the subject as to what's going to happen to my files. So what's going to happen if you have an exSILentia 3 project file and you decide to upgrade to exSILentia 4? Well, first of all, before we go there, it's like anybody that has a license to exSILentia 3 and is upgrading to exSILentia 4, we're not necessarily taking away your exSILentia 3 license. So you're going to be able to continue to use exSILentia 3, which is useful in finishing up any existing projects. Of course, longer term, you want to upgrade all those projects. But for people that use exSILentia Online, you probably see two icons, the exSILentia 3 icon and the exSILentia 4 icon for the near future. Obviously, exSILentia 3 is going to eventually go into maintenance mode. We're not going to make any changes to it anymore. But anyway, so that's, if you're worried about my existing projects, what will happen? Can I leave them in 3? You could, but eventually you'll have to move them over to 4. But for the near future, you should be good. So one of the things to point out with exSILentia 4 is that we have a new file format. And in exSILentia, in the analysis and the design phase, everything revolves around projects. When we go into the operation and maintenance phase in the SILstat world, so to say, we're looking at collecting data continuously. So we're dealing with a more database type format in the back end. But for the analysis and the design world in exSILentia, we work with project files. And the files are easily exchangeable between different users. I can work on a file, I can send it to a customer, or the customer has a file, they can send it to me, and so on. The new file format that we have for exSILentia 4 is the .exp file, and it used to be .exi file. When you want to open a version 3 file in exSILentia 4, there is a converter tool, and that converter will basically take the information out of the version 3 project and implement it in version 4. So as a question, what will happen to my files? A simple answer is nothing. We're not going to do anything with your version 3 file. The only thing that we're doing is we're taking the information out of it. We're converting it to exSILentia 4, but the EXI file by itself is not going to be touched. So we're not, obviously, it's always a good practice to make backups, but we're not changing the .exi file, and you could redo the upgrade to version 4 at many future points in time. We're not touching the EXI file. We're not changing anything within the EXI file when we upgrade that information to version 4. But when you open an exSILentia 3 file and exSILentia 4, we will create a log file. We will show you all the changes that were made to that particular safety function, or all the conversion steps that were taken to that data, and we highlight areas where you may want to look at this, or hey, this is going to impact your calculated result, or and so on. So you can always see in the log file what we did, what happened to your data, and where, if there are any differences in results, what would be the cause, or could be the cause of those differences. So let's look at a couple of items. And again, we're going to focus on silver, but there's a couple of general items that have changed. So for example, when you create an exSILentia 4 project, and you're used to exSILentia 3, you may notice that the company, the project leader, and the project initiated on date are no longer available. So what do we do with that information? we take it and we put it in the project description. So if you've defined a company within the company field with an exSILentia 3, that information is simply appended to the project description of your version 3 project. The same thing with the project initiated date on. The project leader is converted into a team member. So exSILentia 4 works with team members, and the leader flag is set for that team member. So we know that this person is a project leader. He was the project leader in version 3, but instead of having a separate field, he's just part of, or he or she is just part of the team member overview that we have within version 4. Same thing, one of the reasons why we decided to remove the project initiated on date is because we have the ability to define sessions in exSILentia 4, so it doesn't really there isn't really that much benefit in us telling you when the project is started if that's all recorded in the different sessions. So those are some changes that have happened to exSILentia 4. So this is what we do with that particular data. One thing to keep in mind, and last week's webinar has talked about this as well. One thing to keep in mind is that in exSILentia 4, there's a different structure to safety and semantic functions than we had in exSILentia 3, and that safety and semantic functions are safeguards. Well, they're not just any safeguards, they are safeguards that are of type semantic protective function, and that are marked as safety and semantic function. So whenever we encounter a SIF in a version 3 project, when we transfer over that information into version 4, we will generate a safeguard, we will make it of type IPF, and we set the isSIF checkbox to true. So for you, when you go into the silver tool, there's not really any difference. But if you would use that information in the PHA, for example, then you would notice that there's a difference in there, that it's now available from the safeguard library. So during the conversion process, all the SIF identification information is transferred over to the relevant safeguard fields. So your SIF name, safeguard names, and so on. So all that information is maintained, but is just put in a different location. One thing that will impact, or potentially will impact, your safety and semantic functions is that there's a couple of things that changed in exSILentia 4, and one of them is the way that we handle the safety equipment reliability handbook data. In the past, it was a traditional database. It's a more hybrid form now, much easier to use from a programming perspective, etc. But the database backend changed. So what we need to do is, when we transfer information over from version 3 to version 4, so we need to now link those traditional database items to this new hybrid database format. And as part of that, we will link it to the database, but we will also update all the failure rate information that is associated with your equipment. So if your project is very recent and you're using the latest and greatest safety equipment reliability handbook database, this is not going to do anything for you. But if you have an older project where some of the data may be out of date, this will automatically update that failure rate information. So as you know, within a version of the tool, we will not make any changes to your data. You will have to say, yes, I want to update that failure rate information, which is through version 3, which is through version 4. But as part of the upgrade, all your data is going to be automatically updated. Then in version 4, we have a different algorithm on how we handle logic solvers. So we talked about the allocation of I/O channels to the individual I/O modules. I/O channels are part of the sensor and fine element groups. The modules can be part of the sensor and fine element groups depending on how the voting is done, depending on how the wiring is done. So that has changed. You can indicate if you want the I/O channels to be connected to the same module or to different modules. So if I have, let's say, a 2 out of 3 voting, do I want to have all 3 of those inputs go to one I/O module, one analog input module, or do I want them to go to 3 separate analog input modules? We can configure that, but as a result of that, and you know, the settings that we take over from version 3 don't allow you to specify that, but as a result of that, the channel allocation is going to be different. So with that in mind, you know, it's unrealistic for anybody to expect that the silver in version 4 is going to give you the exact same results as silver in version 3, simply due to maybe updating of data, maybe changing of your logic solver channels, regardless of any other parameters that we may have changes to. A significant update of the overall calculation algorithm. So it's it's unrealistic to expect that the results will be spot on. Now, having said that, we're talking about a very, very small difference. We're talking in 1, 2, 3% maybe difference, if at all. The logic solvers tend to be negligible from a probability failure demand perspective, at least in the typical safety function. So the fact that we've moved some things around there, that the I/O channels are handled differently, that's not going to be that big of an impact on your overall calculated probability of failure demand. And we've run thousands and thousands of calculations where we looked at the results, and it is it's in that 1-2% range, if at all. So some of the things that are different in version 4. So if we look at the architecture constraints, one of the things we decided in version 4 is that we're no longer going to support the outdated methods, outdated architecture constraints methods as they were defined in IEC 61508-2000 and IEC 61511-2003. And then you may remember in version 3, we have this option IEC 61511, but ignore clause 1143 for type A devices. That was a result of 61511-2003 being extremely conservative and basically requiring redundant vowels for SIL1 applications. So those selections are no longer supported. And what we will do when we update your data from version 3 to version 4 is we will change those selections to the new selection. So for anything that is used to use 61511, we're now switching you over to IEC 61511-2016. And for anything that use IEC 61508-2000, we're switching you over to IEC 61508-2010. These 3 changes will impact your CIFs. Obviously, if you look at the hardware fault tolerance requirements in 2016 table, there's a significant difference in the required hardware fault tolerance versus 61511. So this will impact your CIF. Now, in all cases, that will be you will be able to use your safety function in higher SIL levels. It will not really impact your overall achieved SIL. It may go up. It will not go down. The 61508-2000 versus 61508-2010, that could actually drop your achieved SIL level due to the different handling of safe failures, as the definition of safe failures was changed in 2010. So that, again, that's something that if you have safety functions that use one of those methods, then you need to look at the results afterwards. The application test method was a selection that we had in that we had in version 3. Version 3 was released prior to the release of 61508-2010, and there was some difference in handling of diagnostics that you would implement on application level. And we are no longer supporting the old method that is in 61508-2000. So that will be automatically transferred over to the new method, 61508-2010, and that will impact your CIF. If you already use 61508-2010, which was our default value in version 3, then it will be an impact. And then something else that we've changed, the sensor group voting, 1 out of 1D and 1 out of 2D, we have removed those. The D is an indication of an independent diagnostic output switch, which isn't really applicable to most transmitters. What the transmitters use are defined output ranges. So, for example, Namur, your 3.6 milliamps or your 21.5 milliamps, dedicated ranges where you drive your outputs to, and your logic solver can then detect those. So what we've done is we've changed those voting arrangements to for 1 out of 1D to 1 out of 1, where the trip on transmitter fault is set to yes, and for 1 out of 2D we change it to 1 out of 2, where the trip on transmitter fault is set to no, which is the exact same behavior that those two voting arrangements have, and they will not impact your SIF. Some conversion actions. So the I/O, the logic solver I/O channel count. In version 3, we had the ability to say user-defined or automatic. In version 4, everything is automatic, based on the ability to define how you want to land your I/O channels. The user-defined option was primarily there to allow the user to do that. Now we can just simply click a checkbox to say how you want to land your I/O channels. You no longer need to do that through user-defined options. Then the tags for the information with regard to the operating ranges and the trip limits. So the engineering unit low, engineering unit high, and the trip limit itself. Additional information that you were able to specify in exSILentia version 3, as well as in exSILentia version 4. One of the things that we are doing is we've converted those fields from strings to decimal values. So you could type anything in version 3. In version 4, it needs to be a decimal value. This is of course important because in our configuration layer, we're using this information to help configure the logic solver. So we need to be able to do that. We need to be able to use those values, and therefore we need to ensure that they're decimal. So we will convert the string to a decimal, and if we're not successful, then the field will be left empty, and again there will be a warning in the log file that you will go and have to look at it. But if you've used this for numerical values in version 3, then the upgrading is not an issue. The converting is not an issue, and obviously it will not impact your calculated probability of failure on demand, because it's just a matter of additional bookkeeping, so to say. All right, I have another question. Let's see if I can. So here's a question: if you haven't defined how you wire your I/O channels, and you change the allocation of the I/O channels, will that change your P of the average? And the answer is yes. If you change your SIF configuration, then the P of the average will change. So if you decide that initially that, let's say 2 out of 3 voting, that the 3 transmitters go to 3 separate analog input modules, there is voting over those analog input modules. If you decide that the 3 channels go to 1 single input module, then there's no voting over the analog modules themselves, only over the channel. So the analog input module becomes let's say a common failure to all 3 inputs. So that will change your calculated P of the average. So it's important that when you start doing your conceptual design, that you have decided on your design principles for your safety and cemented system. This is typically what we've seen is this is something that is decided early on. People tend to want to avoid that common failure potential, so they tend to wire things to separate I/O channels, I/O modules. Definitely when there's many channels that need to be wired, you can easily do that. If you only have a handful of CIFs, then you may need to buy more modules than you need channels. So that may be a more of a trade-off. But it will definitely change your calculated result. Now, the impact isn't significant. It's probably not going to be a high percentage change, but depending on the failure rates of your I/O modules, it could be significant. There's another question here. This question relates to a particular clause in 61508 with regard to how the safe failure fraction is calculated. I think we sent out an email. We had a similar question earlier this year. We sent out an email on that to the people that were attending. So let me do that here again. There's an explanation to this, but it's easier to read what we written down before than me trying to remember exactly what we wrote down. But this has to do with the mean detection time, the mean repair time, and the overall MTTR. And there's actually a contradiction in the standard that leads to some people misinterpreting how you need to calculate the safe failure fraction. So as we usually do, we'll collect all the questions that we're getting here. We'll answer them and then send out a simple PDF file with an answer to all those questions to the people that attended the webinar. So I'll come back to this particular clause in that write-up. And then there's a quick question here, like, okay, what's the difference between 61508 2003 and 2016? I think there is a webinar on that, so I will look up that reference, and I think we've done a series on that to explain some of the differences in the standard. But again, that will be in that written write-up afterwards that we will get out to you early next week. All right. So in addition to some of the changes, some of the names have, some of the descriptions have changed within the tool. The maintenance capability index has been updated to the site safety index because that's really what it is. It is an indication as to your overall health or functional safety awareness of your entire site. It's not something that focuses purely on the maintenance people. Maintenance obviously is a big impact in it, but when we previously talked about maintenance capability, sometimes that was more looked at as a way to be negative towards maintenance organizations rather than looking at an overall site philosophy. So we've updated that terminology. Then we've removed the additional indication that this is IEC 61508 2010 per IEC 61511 and 1145. We've changed that. You just simply say use 61508 tables or use 61511 tables. The user guide talks about the particular clause in the new version of 61511 that allows one option versus another. Then for the sensor group configurations, some things we have been updated there. For what we called previously alarm setting has been updated to transmitter fault direction. So this is where the transmitter will drive its output if there is a internal detected failure. Wanted to get away from the word alarm because per alarm rationalization, an alarm is a notification to the user. I'm not sure if the word notification is correct here, but notification to the user where he needs to take an action. And this may not necessarily be an action to be taken by the user himself. Over range and under range has been updated to out of range detection. The alarm filter and alarm voted as trip have been updated to transmitter fault filter and trip on transmitter fault. So those are just some name changes, but the functionality behind them have not changed. So let's look at a quick demo of importing an exSILentia 3 file. So what I've done here, where is exSILentia? Here is exSILentia. What I can do is simply say open a project, and when I click on open a project, my my standard Windows dialog will show up, and in the lower right hand corner here you see exSILentia 4 project. That's the default extension that the tool will look for, but you can also say I want to look for an exSILentia 3 project, an EXI file. And if I say I want to do that, then here I have a reactor high pressure protection function that I want to import. So I'm going to select that file and simply say open, and the tool will then take that file. It will generate a log. I'm running dual screens. The log file showed up on my second monitor. So here's the log file that it created. If we go to the Silver tool, we can see that here is my reactor with high pressure. We see information being transferred over. So we have specific selections of equipment. We have our proof test intervals and all that. And then we can simply calculate the overall achieved SIL level. In this case, because I'm using generic equipment, my systematic capability is 0, but the SIL limit based on architecture constraint is 3. My SIF meets a SIL 2 requirement based on PFD average. So my only issue here is the fact that I'm using systematic capability for equipment that is not certified. So I have to do proven use justification. Real quick, so we see that information is transferred over. So we see, okay, this is some out of 3 voting because there's 3 separate lags. Some out of 2 voting because there's 2 separate lags for my fine elements. But we see the overall information, so the SIF name, the SIF tag, when it was imported, the tables that are being used. In this case, I'm going to uncheck systematic capability because of the use of generic information. If I go to the sensor part, we see the 2 out of 3 voting. We do see the beta factor that came over, which is not my default beta factor, and so on. So we see that those pieces of information are transferred over, and then on the final element part, okay, apparently it was a 1 out of 2 voting with a particular final element here. So the tool will import that information, and obviously your logic solver may look a little bit different. In this particular case, all the I/O channels go to the same module. So 3 analog inputs go to 1 analog input module, 2 digital outputs go to 1 digital output module, and that's per my settings within my overall SIF. And I can actually, on a per SIF basis, change that. Typically, it's going to be consistent for the entire project. So that was a quick demo as to how I can import information. And I'm focusing on the Silver tool in this case. There are similar changes that we're making to some of the other tools. Obviously, when it comes to the SIL selection tool, because the tool has been updated from a structure perspective, we have a separate LOPA tool. We have a separate SIL selection tool where we could do risk graph risk matrix. Because we have the frequency-based target options kind of split out in a separate LOPA now. Obviously, there's going to be changes when you import a version 3 project in version 4 with regard to the SIL selection. And our user guide has a detailed overview of all the changes that we've made to the tool for the different phases. So anything from importing PHAs to importing SIFs that are defined in Silver, it will show that. If I go to the library, we will see that there's 1 sensor group defined. we will see there is one fine element group defined. We see there's a total of 3 sensor lags. There's a total of 2 fine element lags. If we go to the device models, here are the devices that have been used within this device types that have been used within this particular safety function. In the devices, we see that there's multiple instances of some of these. So, as there's 3 inputs and 2 outputs, so we see there's multiples. So we can see in the library how all that information is also transferred over from version 3 to version 4. All right, and at the same time we see it's a very painless transition. You just simply open up your EXI file and all the information is transferred over. In my example, I'm just using a simple safety function, simple project with 1 CIF. Obviously, in our development testing, we've had projects with hundreds of CIFs. The process takes a little bit longer, obviously, with more information to convert. But the result is similar, if not the same. So that was a quick show of how this import function works. If there are any other questions, feel free to ask them through our Q&A. Oh, and I see one coming in. So there's a question here with regard to the languages of the reports. Some of the reports are available in multiple languages. Not all reports are yet because they need to be updated. In this particular case, the person asking the question says there were some improvements needed in one of the German language reports. Absolutely correct, and we're in the process of making those before we make it available again. So some of the foreign language reports we're finishing up the translations, and they will be available in the upcoming releases that are planned. Then there's a question to demo the SRS report. I can generate a report, but what you will see in this particular safety function, there's no information specified. So this was a pure silver function that I imported. But just from a tool perspective, I can generate a SRS report. Obviously, this is going to not have a whole lot of useful information because I didn't specify anything. For the demo, we made sure we kept it simple and focused on silver, and you can see my original project name here. But you can see in a nutshell as to what the SRS report looks like. With overall requirements, application-specific requirements, general CIF requirements, and then for each individual function, its specific requirements. And as you can see, a lot of the information here is non-existing, empty report because we didn't specify anything. But that's what the SRS report looks like. So I think that's that. So if you're interested in more information, we have a upcoming exSILentia training class specifically on SIL verification, but there's always room to show some more if the attendees are in agreement. It's going to be next week, Tuesday and Wednesday, April 10th and 11th in Houston, and it's going to be in the Houston Marriott North in relatively close to the Intercontinental Airport. If you want to play with exSILentia, if you don't have a licensed exSILentia yet, you can sign up for a free trial on exSILentia.com. Then I would suggest you follow exida on Twitter at exida LLC. We also have a Facebook, LinkedIn, and so on, so you can remain apprised of all information. I will answer any questions that will come in. Feel free to send them to myself. If you're interested in upgrading, you can either open up a support ticket on our website, support.exida.com, and appropriate person will get back to you with upgrade proposal. And with that, I would like to thank you for attending this webinar. I have a little overview here of some other training courses that are coming up. There's another SIL verification course in addition to the one in Houston next week, coming up in our UK office in May in Warwick. So that's something that could be interesting to attend as well if you're in the European area. Other than that, Houston is easy to get to, so feel free to join me next week there. If there are no other questions, then I'd like to thank everybody for attending this webinar, and good luck on your projects. And I hope that that you're going to see a lot of joy in using exSILentia 4. So thank you for attending, and take care.